So we have seen the final output where the 3D model responds to the real-time movement of the IMU sensor. But how do we get from raw data values of the sensor to these meaningful values? Let's understand what is happening inside the STM32 firmware. The ICM-20948 measures the acceleration along X, Y, and Z axis and stores these raw values inside its registers as a 16-bit integers. These values are not much useful in their original form, and if we print these values on the serial terminal, we will get large positive or negative integers as we move the IMU sensor. So to make these values meaningful, we need to convert these raw values to the physical values. In this project, the accelerometer is configured for the plus minus 4G range. So sensitivity for this range is the 8192 LSB per G. That means if we are getting a raw value of 8192, that corresponds to a value of G. So to convert this raw value to a meaningful readable value, we are dividing the raw value by its sensitivity. That is, whatever raw value we are getting, we divide that by 8192.0. So that way, instead of getting the large integers, we are getting the values 0.1G, 0.90, or the 1.0G. That is much more meaningful and human readable. So after converting these all values, we are sending in a CSV format over the serial. On the PC side, our Python application receives the accelerometer and the gyroscope data in CSV format. However, we are not using the gyroscope data as of now. We are calculating roll and pitch on the basis of accelerometer data and moving the 3D model in the real time. You can see that if I am just moving the board, this is moving. In the previous section, we were able to get the raw values of accelerometer and the gyroscope data. So now we have added few more functions which are responsible for converting this raw value to the user readable value. So first of all, we will go to main.c where we are just writing the range for accelerometer, that is, as we had already discussed, that this is configured for plus minus 4G. So first of all, we are setting the gyros accelerometer range to plus minus 4G. So here we can see that for the plus minus 4G, we are just writing the 1 to the register. First of all, we are selecting the correct register bank, that is register bank 2, and then we are writing this range as the 1, which is corresponding to plus minus 4G. Along with that, we are initializing the sensitivity or scale to 8192, corresponding to that whatever value given in the data sheet. So earlier we were using these functions to read raw value for the accelerometer and for the gyro raw value. So now we are using this function, print accelerometer and the gyro value. So first of all, we are reading the raw values from the above functions. Then we are converting those raw values to that actual value. So we are just dividing by this. And then we are printing these values in a CSV format. Our printf is directly to the serial port. In the next video, we will build this Python 3D visualization tool from scratch. So stay tuned.